Okay, so for the first problem, we're looking at rates of change. So for this one, we have let P be the function that gives the cost P of T, okay, in dollars of producing 1 watt of solar energy T years after 1977. Okay, so here's the table. So basically, we want to know which expression best represents the average rate of change. And so when we look at these, let's look at the first one. Okay, so the first one is going to basically be the difference in cost for a solar cell between 1977 and 1987. Okay, so what we're doing is we're basically looking at the change between these 2 points. Okay, so that's not really what we're looking at here. If we're looking at P of 10, that's just going to be the price after 10 years. Okay, so that would be $4.51. Okay, and then we could also do 4.51 minus 80, okay, for this one, and that's going to give us a certain value. Okay, when we look at this one, number 4, okay, this is going to be used to identify the percent change from 1977 to 1987. Okay, and then so that will basically give us the percent change. Okay, and so for the average rate of change, okay, we're going to be using this number right here. Okay, so number 3. Okay, and so what that is going to do, if we plug in those values, okay, we're going to have 4.51, okay, minus 80 divided by the number of years that we have. Okay, so let's go ahead and calculate that. We have 4.51 minus 80, okay, and that's going to be divided by 10. Okay, and so the answer here will be negative $7, and let's just say 55 cents. We're going to round that one. Okay, and so this basically tells us that the price decreases by $7.55 each year on average. Okay, so that is the average rate of change. Okay, so for number 2, here are a table and graph that show the number of coffee shops worldwide that a company had in its first 10 years between 1987 and 1997. The growth in the number of stores was roughly exponential. Okay, so they're letting us know that it was roughly exponential here. Okay, all right, so for the first one, find the average rate of change for each period of time and then show your reasoning. Okay, so let's go ahead and set this up. All right, so for this one, let me go ahead and just scroll up a little bit. Between 1987 and 1990, okay, let's go ahead and set this up. We're going to have 84. Okay, so that's this right here, minus 17. Okay, so if we look at our table, that's going to be the year of 1987. Okay, and then we're looking at 3-year difference. Okay, and so that's going to be divided by 3 minus 0, and this is going to give us 22 1/3. Okay, for the next one, we're going to look at the change between this time here, and that's going to be 272 minus 17 divided by 6 minus 0. Okay, and that's going to give us 42.5. And then for the last one, we have 1412 minus 17 divided by 10. Okay, for the full time is 139.5. Okay, so we're going to make some observations. I went ahead and just copied these down from what's in the text. Let me go ahead and zoom in just a little bit. Okay, so the average rate of change for the first 6 years, okay, is almost double that of the first 3 years. Okay, so we're looking at these two numbers here and comparing those. Okay, so the average rate of change of the 10-year period, okay, that's going to be the entire 10-year period, is almost 7 times greater than that of the first 3 years and more than 3 times greater than for the first 6 years. Okay, and then the company was growing at an increased rate of over 10-year time period. So basically, that's just some of the information that we can get from this calculation. Okay, so now we're going to use the graph to support your answer to these questions. Okay, how well do the average rates of change describe the growth of company in the first 3 years? Okay, so let's go ahead and put this down. So we have an average rate of change of 2 1/3 is a fairly accurate prediction first 3 years but a poor prediction growth much beyond 1992. Okay, so for the next one, let me go ahead and just copy this over because it's going to be a lot neater than my horrible drawing or writing here. Okay, so for B, an average rate of change of 42.5 is an okay prediction of growth over the first 6 years, but it overestimates early on and greatly underestimates the growth in years after 1994. Okay, and then the last one for C, let me go ahead and copy this over. We have an average rate of change of 139.5 does not accurately predict the actual growth of the company between 1987 and 1997. Okay. All right. So let's look at the next one. Copy that over here. Let f be the function so that f of t represents the number of stores t years since 1987. And the value of f of 20, okay, is 15,011. Okay, so then they're wanting us to find the answer to the function and then basically tell us about the change in number of stores. Okay, so the average rate of growth is about 1,359 stores per year. This is 60 times greater than the average rate of change over the first 3 years and almost 10 times greater than the average rate of change over the first 10 years. Okay, and the number of stores continued to grow at an increasing rate from 1997 to 2007. Okay, and so if we go back here and look at number 3, okay, we can see basically what we're doing is we are finding the slope of the line. Okay, and so down here, I basically copy down some information from the text. Okay, so you might want to read through that. Okay, you don't have to copy down the the graph if you don't want to. Okay, but it might be helpful just to kind of get an idea of what exactly is happening with these different functions. Okay, so now let's move on to the next question here. Okay, and so we have this graph. Okay, it represents the exponential function p, which models the cost p of t in dollars producing 1 watt of solar energy. Okay, so we saw this at the beginning. Claire said in the first 5 years, between 1977 and 82, the cost fell by about $12 per year, but in the second 5 years, it fell only by about $2 a year. So show that Claire is correct here. Okay, so when we calculate this, we're going to have, P of 5 minus P of 0 over 5 minus 0. Okay, this is approximately negative 12.2. Then we have P of 11 minus P of 6 divided by 11 minus 6 is approximately equal to negative 2.17. Okay, so we can see that she is correct. Okay, so the next question, if the trend continues, will the average decrease in price be more or less than $2 per year? And then explain your reasoning. Okay, so from the first 5 years to the next 5 years, the rate slowed down. So if the trend continues, the decrease in price should be less than $2 a year. Okay, and see, when we look at the graph, okay, we can see that, let me pull up this. If we look at our rate of change here, okay, so we're basically looking at the slope. Whoops. Okay, we can see that it's a steep slope. Okay, if we look over here and we look at like this slope, we can see that it's not as steep. Okay, so it's going to be less. Okay, so it's basically being able to interpret the graph and looking at the slope between those points. Okay, so let's take a look at the next one. All right, are you ready for more? Sorry, I just need to get to my... Okay, so basically, suppose the cost of producing a watt of solar energy had instead decreased by $12.20. Compute what the costs would be each year and plot them on the same graph shown in the activity. Okay, so let me go ahead and copy that over. Okay, so the alternate costs with constant decrease would be the same in 1977 and 1982 and higher for each year in between. Okay, and so when we look at these different points, dependent on the new decrease, okay, we're going to get a graph that looks like that. Okay, and as always, remember to take a look at the summary.